Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. If you have any questions throughout the training session, if you're on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that. You can type in your question, hit submit, and I'll get to those at the end of the session. If you're watching along on YouTube, feel free to use that live chat function wherever it happens to be on your screen. Type in your question or comment, and I'll get to those at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. And before that, it was 8 years at Subaru. So I worked at a dealership, and over time, I guess, just became that diag guy in the shop, right? Always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type problems that would come into my day. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today, we are continuing on with our component testing series we've been doing. We're going to focus on one main type of component, how it works, how it operates, how we can test it, and maybe some other things we might be able to do when it comes related to that topic. So today, the component is speed sensors. So there's a couple different types of speed sensors we'll see on a vehicle, mainly wheel speed sensors, transmission speed sensors, and vehicle speed sensors. Sometimes some are used for other purposes as well. So a couple different types of sensors we'll be talking about. We have analog sensors, which would be more of it like an AC type pattern. Digital sensors, kind of like a Hall effect sensor. We also have Magneto-Resistive sensors. There's also some mechanical speed sensing devices, so to say. We also have the inductive type, which would be more of the analog. As I said, Hall effect, and then Magneto-Resistive, which would be more of a digital type sensor. Wheel speed sensor, of course. Multiple types of transmission sensors. So we have turbine speed sensors, input speed sensors, output speed sensors. There can be multiple input sensors, multiple output sensors, multiple speed sensors on a transmission. And then, of course, a couple different ways of measuring vehicle speed as well. So the first one we're going to talk about, it would be kind of your classic, back when we first, with the wheel speed sensors, first started doing this. We have this inductive sensor. So the inductive sensor and the Hall effect sensor work similarly. In this case, the inductive sensor is that if you pass alternating current through a coil of wire, so we have alternating current coming through here, goes through this coil of wire, it's going to produce an alternating magnetic field around it due to this magnet here as well. So it'll have a magnetic field. And then if we move a conductive material, so this ferromagnetic rotor in this case, so ferromagnetic, ferro means iron. So if we have iron or a magnetic iron, steel, that sort of thing, something that's magnetic, passing through that, it will generate a current through that. So the ECM, TCM, whatever will read that current, and it'll see it going through. So as I said, creates a magnetic field. And then it goes down and it creates a little bit of a small current there. So we'd be used to seeing these. We've been around for a long, long time. Just be something like we got that encoder wheel on the outside of this axle here. So that'd be for wheel speed. You just have the wheel speed sensor up there to be measuring that. They've been around for many, many, many years. Now we could have, when we test it, oftentimes these inductive sensors, these older style classic type sensors, is going to be emitting more of an analog type pattern. So every time that little tooth goes by, we're going to see an up and a down and up and a down and an up and a down. As it goes by, they're generating that current. So we'll be usually, when you'll see this on a scope and you're testing it with a scope, you'll see AC. So it'll be centered around 0. It'll go up, it'll go down. You'll have positive and negative flow as it goes up and down there. So you'll be able to see that. Now, what happens if we have a problem with one of these types of sensors? So it's going to be very similar to how an inductive or a Hall sensor would react to this. But let's say I have here's another one of the wheels that's damaged. Right, we see maybe we got some rust, or maybe we have it's broken, that sort of thing. If that happens, if we have some sort of a contamination, something like that, it can cause all sorts of strange issues, and it might not necessarily set a code. Think back to my mother's vehicle. So she used to have an '01 Ford Explorer, and it would do the strangest thing. Anytime it would come down to a stoplight at one point, or stop sign, or just come to a dead stop, no matter what, could be bright, sunny, 80 degrees out, hasn't rained in a week, and the ABS would fire every time. Hot, cold, wet, dry, didn't matter. As soon as you came down to like below a couple miles an hour, the ABS would fire. And it took them a little while to figure out. What it ended up being was the wheel, the metal wheel on the axle on the front was rusty. It was a little rusty. It was causing the signal to drop out, which the computer thought that it was the wheel stopped moving. So if the wheels stop moving, obviously it thinks it's skidding, so it's going to pump the ABS solenoids and the brakes there because it thinks it's skidding. Cleaned it off, had no problem after that. Happened to me a couple of times in the Subaru dealership as well. We had a few cars that did the exact same thing. When it came to a stop, it would feel like it was going off, and then it ended up being, either the axle was broken or chipped or worn or rusty or what have you, some sort of damage with that. So to just give you that same example that I gave you before, we got a couple of these that are rusty or damaged or what have you. It's going to go by, and then all of a sudden we have a dropout when that happens. All right, so if we have a dropout in the signal, according to the computer, well, it's not moving. So depending on the age of the system, some of the newer systems I'm sure can figure it out, but with these older systems, these AC sine waves, it might just say, oh, well, I no signal, but all the other wheels are moving. That wheel must be skidding. So it gets confused, and then it just fires the ABS when it's not supposed to. I've seen it happen. So if you were to look at that on a scope, we got a component test here. So on the same '01 Ford Explorer like my mom had, you see I got a positive and negative, so it's an AC voltage going through. And we see that coming out, we have AC voltage as well. So there's zero, that's right down the middle. We have a positive, we have a negative. The faster you spin the wheel, in just about any case with these wheel speed sensors as well, as the wheel speed changes, the frequency and min-max voltages will change. So on an AC, the frequency gets closer together, so my bumps get closer, and they also get taller. So it's like you're squishing them up, and they get closer together and they get taller. When they slow down, the peaks get smaller, and it's like it spreads out. So depending on how fast, if you're just turning it by hand, it's not going to go all that fast. It's going to be more kind of like a look like this, where it's kind of slow because you're pushing on it, right? So that's my standard, say, call it passive sensor. We also have on most modern cars, they're going to have these magneto-resistive sensors over here, and those work similarly. They work on the magnetic field, but they have these digital sensor chips in here, and it converts it into a square wave signal. And what we have, instead of having just a metallic knurled wheel like we had with the axle I showed earlier, on this, most times they're built into the wheel bearing, and it's going to be in the actual rotor itself is magnetic. So usually it's in the inner bearing race. It's going to be covered with some things, and then depending on the polarity as it goes by, it's going to send a signal to these two magneto-resistive sensor components. So we got A and B. Another thing this does for us, and not every manufacturer does it this way, but some manufacturers do it this way. It can also sense direction. So am I moving forward? Am I moving backward? So if the computer needs to know whether it's moving forward or moving backward, it's going to be able to detect it because it has these two sensors next to each other. So if one goes high first, so let's say A goes up high and it's reading a pattern first, then it's going to output a square wave, and that indicates to the computer that it's going forward. So it's moving that way. If it's going moving backwards, the B sensor will read it first. So as it's going that way, the B sensor reads it first, and then it's going to put out a modified square wave. In this case, we get a taller peak, and then it kind of drops out. So that indicates to the computer that it's moving backwards. Some manufacturers use magneto-resistive sensor, and they don't care about what direction the wheel is moving. Other manufacturers do, and that's able to indicate whether or not it's going forward or backward. But if I was going to try and read this, trying to test this with a scope, and I'm moving my wheel forward and I see this, but I move my wheel backward and I see this. Well, what's going on there? If you didn't know that it put out a different type of pattern when it's going in the opposite direction, you may be prone to think, if you only spun it backwards, for example, that, hey, that's a problem because that doesn't look like a square wave I've ever seen. Right? So being able to see that and understanding what the pattern is supposed to look like to be very helpful. Here's just an example on a 2019 Acadia. It's got that similar type of magneto-resistive sensor. So it's going to have signal at a low reference. Wheel speed sensor is a 12-volt digital sensor. The EBCM, which is the electronic brake control module, sends a 12-volt reference voltage signal to each wheel speed sensor. As the wheel spins, the wheel speed sensor produces a square wave DC signal voltage, and it's not very large. The wheel speed sensor increases the signal frequency as the wheel speed increases, but does not increase the signal amplitude. So as we said before, the frequency gets closer together, but the height of the square wave does not change. Best test location is going to be at the wheel speed sensor connector, and then they give you a rear connector as well, and then each component is located at each wheel hub or suspension and steering knuckle assembly. So if you were to test it, it says lab scope should be used to check the waveform signature integrity. As the wheel RPM changes, the frequency will change. It should look like this. And notice how it's not a huge change. It's a volt up and down. So this is designed to read just the difference that's coming back. So it's sending out 12 volts, and then it goes up or down a little bit by the difference. So you see it goes like 0.6 of a volt up to like 1.6 volts in this case. So it just goes up and down a little bit. It's able to detect the change. Also on this Acadia, and this is going to be pretty much across the board, it's going to be the same type of deal. On some vehicles, the following DTCs or symptom codes may be set. See 0035, 0040, 0045, and 0050 sets each wheel speed sensor. In addition, the following lights may be illuminated: the ABS, service traction control, and/or service StabiliTrak system on there as well. This may be caused by bits of ferrous magnetic debris stuck to the wheel speed sensor magnetic encoder ring. So we got our secret encoder rings. And they, as we said before, they have a north and south pole, so they're magnetic. So that means anything metal that contains iron, including rusts, can get on there and it can get stuck on there. And then it's going to cause interference in the signal. It'll cause a problem with the sensor being able to read it. These vehicles use a speed sensor encoder ring with north-south magnetic pole pieces encased in a nitrile rubber ring, typically brown in color. This ring is a part of the wheel bearing, so it's all in assembly. If you're experiencing any of these systems, this ring must be cleaned using a soft nylon bristle toothbrush or equivalent. If any debris still remains, a mild soap detergent may be used. Wipe dry after the procedure is done, and then use care to prevent damage to the wheel bearing seals. So you want to make sure you clean it up real well. And also don't use any kind of magnetic tool to remove this debris, or the encoder may be damaged. So the first thought that someone might make if they hadn't known this, or they hadn't read this, or it's the first time dealing with one of these, was, well, it's got a bunch of metal on it. I'll just use my little magnet and just go around it and pick it all up with the magnet. Well, in that case, you could demagnetize that encoder ring and cause an issue, another issue you weren't intending. So just clean it as it says, and you should be okay. Here's an example out of a TSB from GM as to what that might look like. We got a bunch of dirty stuff all the way around it. We got the inner bearing there. We got the encoder wheel on the outside. This is a digital drawing, so it's not the best real world example, but you kind of get the idea. You get a bunch of stuff in there in the encoder ring. It's going to cause some issues. Also found a TSB when doing research on this on Volkswagen Passat. Now, on a Volkswagen Passat, apparently, if it has one of these encoder wheels, apparently the left and the right wheel speed sensors are different. One is longer than the other. So if I put the wrong one on the wrong side, and apparently they're interchangeable too, because I don't think they'd have this bulletin out if it hadn't happened before, but we can see where it kind of wore out on the back of this wheel bearing. Now, the wheel bearing itself is not color red. That is just drawing attention to that encoder that is totally destroyed because it was rubbing on that speed sensor. So just be forewarned. There may be vehicles like that where the tolerance is too tight, or maybe there are different sides for different bearings. So you just got to be aware of it. That's all. And if you damage it, well, then guess what? You got to replace that wheel bearing you just replaced. So just be aware, be careful. Here's just another example of this is on a 2013 Dodge Charger. Uses a very similar type system we've just been talking about. So raise the wheel in the air. As the wheel spins, the sensor will produce a square wave that varies about 400 millivolts, cycling between 10.4 and 10.8 volts. And the meter is set to focus on the pattern. So we see how it goes up and down, AC on the other side. And we can see how it just kind of goes up and down as it turns on and turns off. So that's just another example that was on a notebook. All right, so that is wheel speed sensors by and large, or just kind of generalized how a speed sensor works. Let's talk about transmission speed sensor. So transmission speed sensor, oftentimes, especially the more modern ones, we could still use those inductive sensors, but usually on a more modern vehicle, it's going to be a Hall effect sensor. So that works on a similar principle as the inductive sensor, except the inductor sensor is generating its own AC magnetic field. And this one goes a different way. So in this case, we have a conductor supplied by a constant flow of current. And if we move a magnetic object over it, a voltage will be produced across the material. So this senses magnetic field and generates a voltage that way instead of having the current change. That's a voltage. Reads input speed, output shaft speed, turbine speed, etc. How we're going to test this is we're going to test for voltage resistance. There can also be a signature test. Sometimes it's part of a valve body on the vehicle, and in that case, it can be difficult to access as well. There's an example on an 09 Subaru Legacy. So these have two speed sensors, an input and output. Turbine speed sensor 1 measures trans input shaft speed and torque converter speed on 1. Turbine speed sensor 2 measures the transmission speed. Speed sensor 1 is located on the driver's side of the transmission near the middle of the transmission, so it can get damaged when you're moving your transmission in and out, by the way. Speed sensor 2 is in the valve body, so that one's easy to get to and replace. The other one, you got to drop the valve body to get it out. So it gives you two different places to check it as well. So we have the sensor itself, the 3-wire sensor, Hall effect. And then number 2 is access through the main connector on the transmission there as well. So we can see in this case, it's going to be just a DC voltage test that we can do on that. So turbine speed sensor positive, black to no good ground. The sensor positive voltage when the vehicle is stopped should be nothing. And then when it's at least 12 miles an hour or more, we can have 1 volt AC and it should go up from there. So in this case, we're seeing the voltage RMS, AC voltage RMS on that. It just kind of reads it as a numerical value, digital value. Another example, how I mentioned that sometimes they can be difficult to access. On this case, we're looking at a GM. I believe this is off the 8-speed transmission. And as you can see, we got the transmission control modules kind of part of the valve body. And then this is the input and output speed sensors. It's all on the same harness, so they're not separate. And then it plugs into the computer by itself. So really not that easy to get at this to actually test the component itself. Oftentimes, to have you diagnose this, they would have you diagnose it using PID data to make sure that it was working properly. So how about vehicle speed? If we go back, way back to vehicle speed sensing, so to say, we have this, we have the cable. If you remember back in the day, we had these flexible cables. It's got a little part that goes into the transmission on one end and it goes into the speedometer on the other end. As it spins around, spins some gearing on the back of the speedometer, makes it go up or down, depending on how fast it's spinning. So that's the old way of doing it, as we know. And then a little further on down the road, they came up with the idea where it's kind of mechanical. It's going to kind of spin, but it's going to turn it into a signal that the computer can read at that point. So in this case, this does not have a gear on the end. It would go into a gear. And then in this case, it does have a gear on the end. It's just two different manufacturers, two different OEMs for this. But you notice something about this gear as well is they're made out of plastic. So when that plastic can go in, sometimes it can be worn out. They call it a drive gear and a driven gear. So this is the gear that is driven by the transmission. And you can see it's all wore out. It's also stained. As you can see, it's kind of blue in there, just like this blue one over there, but it's been stained by the gear oil on this particular vehicle. It's probably a manual transmission. It's usually when they use these for. So if you have any other transmission problems internally, maybe it might wear out. And then you wonder why your speedometer's not working. That could very well be why right there, because that driven gear is worn. It's very common on these plastic gears. And then also related to vehicle speed, what if I change my tires on a vehicle? What if I got a Jeep, like a 2014 Jeep Wrangler, and I change to like some 44-inch tires or something like that? How do I assure that my vehicle speed is correct? Because oftentimes as well, I didn't mention this, but oftentimes manufacturers will also use wheel speed now. Instead of having a vehicle speed sensor on the transmission, they'll just use wheel speed to know how fast it's going down the road. And it'll use the, like I said, the wheel speed or the transmission output speed or what have you. So depending on my tire size, my speedometer can be way off. So you would need to go in and do a reprogram of that. So we're actually going to walk through that. That'll be the first part of our live on tool session here. So I got my 2014 Jeep Wrangler loaded into my tool. And let's go into the scanner and walk through that function. So different vehicles, it's going to be in different places. On your Chrysler, Dodge, Jeep, Ram vehicles, in this case, the 14 Wrangler. When it's available, it's going to usually be in the central gateway. Sometimes it can be in the tire pressure monitor, but usually it's in the central gateway module, which is like their vehicle's body control module. Also have it available on some GMs and some Fords as well. In this case, it's going to be on miscellaneous functions. And you see we have user options for the body control module as well as program tire size. We go into program tire size. It says this function is used to program the tire size into the TIPM. Continue. In this case, the current tire circumference is 771 millimeters, which does not correspond to a known tire size. Continue to enter new size. That'll be fine. And then it gives us choices. Generally, it's going to be here's what would be on this vehicle normally. So we got 225/75 R16s up to 245/70 R17s, 70 R18s right there. So it just depends on the vehicle, what it's equipped with. Now, if it's none of these, like for example, it's 44-inch tire, we can go into custom size, program a custom size, measure the circumference of the tire in millimeters, and enter the value on the next screen. So I didn't look up how much of the circumference of a 44-inch tire is, but you can enter anywhere from 570 millimeters to 11,500 millimeters. So let's say it's 10,000 millimeters. We hit the check mark, say it's okay, hit the check mark again, and it says program tire size is successful. Please run the initialized electric gear switch procedure at present as well. So if you have that function, you need to do that. It's found in the TCM under miscellaneous functions. Then cycle the ignition for a minimum of 30 seconds, clear all DTCs. And if ABS is displaying vehicle configuration mismatch, run the initialized ECU procedure, find the ABS module as well. So you may have to reset a couple other modules in order to do that. Now let's see, let's just see on this vehicle, electronic gear shift, if it has an initialized thing. I actually honestly haven't checked this yet, so it may or may not have it. We'll see. So let's see, electronic gear shift. It does not have an electronic gear shift module. That's probably a little too old, so that's fine. ABS, there is also another one in the ABS module that it may or may not have under miscellaneous functions as well, and that has an initialized ECU in there. So we may need to do some extra functions, but in this case, it's shown on the scan tool. What we would need to do, it's shown right on the screen, which is kind of handy. Also, let's take a look at the guided component test and see what we can test on this vehicle. So for example, ABS, so that'll be wheel speed sensors would be available there. Going to wheel speed sensors, we go to component information on this 14 Jeep. This sensor is a Hall effect type switch that measures vehicle speed by measuring a reluctor wheel located at each wheel. As the wheel spins, a digital square wave signal is produced. There's no separate signal wire. The signal is superimposed onto both signal wires. So you'll see a difference in signal. Signal frequency will increase with an increase in wheel speed. The ABS module uses the signal as a vehicle speed input, and by monitoring wheel speed sensor signals, can detect wheel slippage. Signal may also be used for cruise control. Control module sends 12 volts of power to an integrated circuit in the sensor. The integrated circuit supplies a constant 7 milliamp power supply to the analog brake module. The relationship of the magnetic pole encoder to the permanent magnet in the sensor signals the IC to enable a second 7 milliamp power supply. The output of the sensor sent to the analog brake module is a DC voltage signal with changing voltage and current levels. The ground for the IC and the current sense circuit is provided by the module. When a pole is properly aligned with the sensor, the voltage signal is approximately 10.4 volts and a constant 7 milliamp current is sent to the module. As the magnetic pole encoder rotates, the encoder shifts the magnetic field and the IC enables a second 7 milliamp current source. The module senses a voltage signal of approximately 10.8 volts and 14 milliamps. The module measures the amperage of the digital signal for each wheel. This resulting signal is interpreted by the anti-lock brake control module as the wheel speed. So it uses varying current and varying voltage. As like you said, it's not a lot of difference in voltage, 0.4 of a volt either way as it spins. Electrical testing can be done at the connector in the harness, about 18 inches from each sensor. Tone wheel is integral to the hub and bearing assembly. So in this case, you would not want to disconnect it because we need power flowing to it as well. Front wheel speed sensors mounted in each knuckle. Caliper and rotor must be removed for replacement because you have to remove the wheel bearing. Actually, no, not for the sensor. For the wheel bearing, you'd have to do for the encoder. Rear wheel speed sensors mounted to each rear knuckle. Tone wheel is integral to hub and bearing assembly in that case as well. So we can go in there as a current test you could do, DC voltage test, and a signature test in there as well. Now, I always like doing a signature test just because it'll show me what's going on. So it should be a 400 millivolts cycling between 10.4 and 10.8 volts. And then we have the pattern up and down. So it's going to look very similar to that Dodge Challenger I showed a little bit earlier. All right, so that's scanner function I can do on that. And that is also a test that we can do using that encoder wheel. Another one we can look at is the BMW. So I got my BMW demo board here. We can go look at that. ABS. So we have wheel speed sensors as well. So in this case, component information is a 2-wire Hall effect sensor. Use supply signal near 12 volts and a shared ground and signal wire. We can see it's very similar to what we were just talking about on that Jeep. The voltage flow through the Hall element is effective when it rotates. This produces a square wave input signal to the control module. Current BMWs use 4 active wheel speed sensors that work on Magneto-Resistive principle. These gray shielded wheel speed sensors can detect if the wheel is moving forwards or backwards. So that's one of the ones we were talking about before, whether it'll go forward or backwards. When the vehicle is in reverse and the brakes are applied, more braking pressure is needed at the rear wheels than the front, since the weight is shifted to the rear of the vehicle. When braking while traveling forward, more braking pressure is needed at the front wheels, since the weight is shifted to the front of the vehicle. So that is one reason a manufacturer might want to know, is the vehicle traveling forward or traveling backward? It's kind of cool. All right, so let's see. Also, tech note, in this case, this is probably good to know. Wheel speed sensors rarely fail on BMWs. If there is a fault, check the signal from the sensor as well as the wiring and connections. Also check for proper gap, correct bias voltage, etc., before condemning the sensor itself. So it might not necessarily be the sensor itself that's causing the problem. Could be something else. Looks like more than likely it's something else. And it is a shielded wire in that case. So it's a little bit different. In that case, we have a signature test and an outer range null signal test that we can do as well. So the signature is probably going to look pretty similar. All right, so we can go in here and we can check it. Spin wheel by hand for best waveform. As wheel speed changes, frequency will change. With all-wheel drive, it may be difficult to spin by hand. Raise the vehicle on the lift, and then with the help of an assistant, place in drive and allow the wheels to spin. Traction control off. Also remember that too. If I'm testing wheel speed sensors and my vehicle has traction control, and I put it up in the air and I let the wheels spin, even just slowly, just at an idle, it could cause the car to freak out. So usually there's a button to get rid of, turn off traction control, because it'll just think the wheels are spinning, and no load on the engine. So that's a traction control problem. So it usually pulses the ABS, flips out, does all sorts of weird things. So if I wanted to hit V-meter in this case, you'd be able to see what's going on. Now in this case, it's a little bit more of a signal than what we can see here, but you'd be able to see it going up and down like that with the signature there. So a couple different tests we can do. Let's see. Do we have one for transmission in here as well? Let's see. No, we don't have a transmission speed sensor on this one. I was on the Jeep. That's what it was. On the Jeep, we had one. Transmission, nag, and we have a bunch of different information here, but we do have input speed sensor. So it's speed sensor 1 and speed sensor 2. Component information on these. So this sensor is a Hall effect style sensor that measures the rotational speed of the input shaft. When the tooth of the reluctor wheel passes through the magnetic field created by the sensor, voltage drops low. When the tooth passes and the sensor measures a gap between the reluctor teeth, voltage rises. As RPM increases, the frequency of the signal will increase. Input speed sensors are 6-volt Hall effect switches. 2 sensors are used as there is no tone wheel on the input shaft, and neither drive element is used in all gear ranges. Input shaft speed is calculated value. So we can see where we would plug in for any of the information on the transmission. We back up, we can go to a DC voltage test or a signature test. In this case, we do the signature test. Input speed sensor 1 will generate a signal in any gear except reverse. Start engine compare. And then there we go. We get a 5-volt square wave. And then up here it says we're supposed to have a 5-volt square wave. So it looks like we'd be in good shape. If we have anything missing like that, it could indicate a problem with the reluctor wheel, something of that nature. If we have a shorts to ground, shorts to power, we could have some problems. All right, so that is my time today on speed sensor. So hopefully we got a couple of little key takeaways on what speed sensors do for us, a little bit of how they work, and so on. So next week, we're going to shift gears a little bit, and we're going to get into a topic we don't really talk about too much so far on this channel. That's going to be body shop diagnosis. So collision repair shops. I think it's a lot more common now than it has been in maybe the past 4 or 5 years, but body shops definitely do need scan tool functionality. So we're going to talk about how we might be able to incorporate that into the maybe the estimating workflow, how we might incorporate it into the shop. I know there's a lot of shops that have gone on board with it, and the collision shops, but a lot of shops still haven't gotten on board with it as well. So we'll talk about a lot of the more body shop specific things, like maybe reprogramming seats, things of that nature that you might need to do in a body shop, airbags, things like that. So definitely come check it out. If that's of interest to you, snapon.com/OT to join on Zoom, 6 and 9 Eastern, as always. The 6 p.m. Eastern goes to YouTube, as we're doing right now. So if you go to youtube.com/snapon diagnostics. If you are watching on YouTube, please make sure you're subscribed and you ring that notification bell so that you'll know anytime we go live with new content. We got a lot of new stuff coming out in the next few months as well. So you'll definitely want to be aware and check that out. 9 p.m. also goes to my Facebook page. So any previous live stream topics as well. So any of the other topics you may be interested in, like ADAS or data bus testing, things of that nature. There's 45 different topics that we've done on this type of format. So if you wanted to go check any of those out, they're all about 30, 40 minutes long and so on. So you can go check those out on the YouTube channel as well. Snap-on Diagnostics is the username, and there's a playlist for live training. So let's get into questions. There's a couple different, I see quite a bit of activity on YouTube there. Looks like no questions on Zoom so far. So if you do have a question on Zoom, just use that Q&A button just to ask any questions. Also want to mention my buddy Al. Al also does free diagnostics training on our scan tools, and it's scan tool specific training. So if you go to snapon.com/OT to register there, that is on Zoom to reserve your seat. Mondays he teaches on Apollo, Wednesday is on Zeus, and Thursday is on Triton. So for all of these classes, it's going to be let's get your tool set up, make sure it's working properly, and then we'll give you a guide through a lot of the buttonology and walkthrough of fast track intelligent diagnostics. So it's everything from let's make sure your Wi-Fi is on. There's a lot of functionality that you lose if your Wi-Fi is not on. Also, we'll set up your free Snap-on cloud accounts. It allows you to share files with your own customers and things of that nature. And then, as I said, walk through fast track intelligent diagnostics. That's the first hour. On Wednesday and Thursday, since Zeus and Triton also have scope and meter functions, he takes a 5-minute break, and then he goes for another hour on the scope, the meter functions, and things like that, some real world examples that you would see. So definitely worth your time to check that out. Same time and place, 5 and 8 Central, 6 and 9 Eastern. Go to snapon.com/OT to sign up for that as well. All right, so let's look at questions. So we got one coming in on the Zoomy. Andrew asks, have you seen any issues with aftermarket speed sensors and wheel bearings with reluctor wheels compared to OEM parts from the factory dealer? I would say, personally, years ago, we would see problems with that just because of quality issues, quality control issues. The reluctor wheels weren't quite set up the right way. And sometimes you would have some issues with reading signals, and you'd have to go through a couple of new parts in order to get it to work. I'd imagine on more modern vehicles, especially, let's use that Passat for an example. What if I get an aftermarket wheel speed sensor on that Passat and it's not the right size? It's too long. Maybe they just decided that, oh, they must both be the same, and they're not. And then it'll cause an issue there where it might rub on that wheel bearing and destroy the wheel bearing. I've heard stories of people with bad wheel bearings as well. You replace the wheel bearing with a brand new one. The wheel bearing itself is fine, but the encoder wheel is messed up. If you drop them, sometimes it can mess up the encoder wheel as well. So definitely could be some issues back and forth. I think you're probably going to run into very similar issues with just about any part on a vehicle. I will say on Subarus too, with reman axles, you got to make sure they're both the same size. Ran into that problem many times, where one's a little longer than the other and it causes a vibration at idle. So that's kind of related to the reluctor wheel because it's pressed fit part of the axle. But yeah, definitely check that out as well. Let's see. So Abel, hi, welcome. Thanks for joining us again. Raymond, Yonkers, New York, thanks for joining us as well. Nick, always welcome from the UK. Let's see. Ram 50 V8 just traded my Solus Edge for a Triton V10 yesterday. Excellent. Stepping up to that guided component test capabilities. Excellent. Let's see. Raymond, Solus Legend, he says, isn't that great? I don't know, man. Solus Legend, as far as any of our scan tools, Solus Legend, Apollo, Triton, any of those will be able to have the same scanner functions anyways. You don't have the guided component test, but you do have the same scanner functions, plus the motorcycles as well. Let's see. Baja Joe checking in from San Antonio, Texas. I'll be happy to hear that Snap-on finally convinced me to get out of my Veris Edge. Upgraded me to Epic EUV for a great deal and made me eligible for crazy discount on the Zeus. Excellent. It's a great step up, Joe. I hope you'll like it. The intelligent diagnostics, I really like it myself just because it saves me time, right? You may not need it. You may know kind of where you're going to go to diagnose things. But I just like the fact that everything's right there. It saves me time. I can still do all the other stuff in there. So I think once you play around with it a little bit, I think you really learn to like it there. Hussein, thank you for checking in. Say thank you. Baja Joe also asked, why doesn't Snap-on Scope have math channels? That's a good question. And I will add that to my list of things that I talk to them about as customer requests for that. No math channels. It does do your addition, subtraction, and differences. So it's got the delta time and the delta voltage. Maybe that's why they don't have the math channels there, because they do it a little bit differently with the math channel. The delta might be a little bit. There's probably a couple other things to be able to do if we had math channels on there, but yeah, definitely no math channels on there. I am no sleep. Great username, and thanks for sharing. Always appreciate it. Yes, Sin, first time joining a live session. Hope we'll join on the next one. Sure, absolutely. Always here at 6 Eastern on your YouTube channel. So check that out. Let's see. Let's see. Nick asks, when's the best time to set up your trigger on your scope? So it really depends on what you're trying to do. I usually it depends on the signal, really. So if I want to see a little before and a little after, I'll set my trigger up kind of in the middle, so I can catch that pattern kind of in the middle, like on a fuel injector. I always do that because they put it off to the side. I like put it in the middle so I can see what's going on before and after. Also, if you're trying to catch a short to ground or short to power, you want to have it either on the falling side or on the rising side, depends. So you can set that up as well. Let's see. Ooh, that's excellent. Okay, good tip with Joe. Baja Joe mentions, so this goes along with my question I had on Zoom from Andrew. So they're talking about aftermarket parts. So Baja Joe says aftermarket Ford Triton chains and phasers will always have a cause of comeback just because the chain link edges are too square and get picked up by the sensor. So there you go. Some good advice there as well. Baja Joe also says the screen resolution was worth it and the Windows 10 upgrade as well. Plus you get the S7 module with that as well. If you didn't have it before, you may have had it before. But all good things, all good upgrades worth it. And definitely you get a good bonus with that deal with the EUV as well. DJ says, hi, thanks again for the training. Missed it all, but we'll rewatch it. That's fine. That's why we record them. So it'll be available, in the next, I don't know how long it takes YouTube to make them available, but it'll be available whenever that is. So definitely check that out. And best use feature for Joe says, best use feature would be a quick lookup for Ford fuses. There you go, quick lookups. All sorts of different lookups on there. Shipping the guided component test. We should have some fuse stuff in there as well. So definitely thanks for that, everyone. Oh, I got another question in here. Hello, Richard. Oh, Rich Dunbar. Hello, welcome. Welcome to the Zoom session. Thanks for joining me as well. So with that, looks like we got through all the questions, comments, and so on. So with that, thank you very much. I definitely appreciate it. Had some good conversation back and forth tonight. I always enjoy that. Hopefully, we picked up a few tips and tricks on your speed sensors and inductive sensors and Hall sensors and things of that nature. Hopefully, you can join me next week for body shop collision repair type diagnostics as well. Enjoy the rest of your week. Enjoy the weekend. Have a good evening or whenever it is, wherever you are, and take care.